Rainbows are beautiful, aren't they? They captivate our imagination and bring a sense of wonder. They appear after a storm, a symbol of hope and peace, reminding us that beauty can follow even the darkest times. But what are these colorful arcs in the sky? Rainbows are optical phenomena, fascinating illusions created by nature. They are illusions formed by the interaction of light, water, and our eyes, a perfect blend of science and magic. Imagine a sun shower, a brief moment when rain falls while the sun shines, creating a unique and fleeting spectacle. Sunlight appears white to us, but this is just an illusion. This white light is actually a mixture of all the colors of the rainbow hidden within. When a beam of sunlight enters a raindrop, something magical happens. A transformation begins. The raindrop acts like a prism, bending and playing with the light. It bends and separates the different colors of light, revealing the hidden spectrum. This process is called refraction, a beautiful dance of light and water. Light travels at different speeds through different mediums. It travels faster through air than through water. When light passes from air into a raindrop, it slows down. This change in speed causes the light to bend. The amount of bending depends on the color of the light. Red light bends the least, while violet light bends the most. This separation of colors is called dispersion. Imagine each color of light taking a slightly different path through the raindrop. This separation of colors is what gives a rainbow its characteristic arc shape. Inside the raindrop, the separated colors of light travel to the opposite side. They hit the inner surface of the raindrop and reflect back. This reflection is like a mirror reflecting light. The reflected colors travel back through the raindrop and exit from the other side. As they exit, they are refracted again. This second refraction further separates the colors. Now, the colors of light are spread out even more. They fan out, forming a cone of colors. Our eyes perceive this cone of colors as a rainbow in the sky. But why do we see a bow shape? What is it about the interaction between light and water that creates this beautiful phenomenon? The shape of a rainbow is determined by the angle at which the sunlight is refracted and reflected within the raindrops. When sunlight enters a raindrop, it slows down and bends, a process known as refraction. This angle is always around 42 degrees. After the light is refracted, it reflects off the inside surface of the raindrop and is refracted again as it exits the drop. When we look at a rainbow, we are seeing light that has been refracted and reflected at this specific angle. This double refraction and reflection process is what separates the light into its component colors. All the raindrops that reflect light to our eyes at this angle form the arc of the rainbow. Each raindrop contributes a tiny part of the overall spectrum we see. The rainbow appears as a semicircle because the horizon cuts off our view. The ground obstructs the lower part of the circle, making it look like a bow. If we were to view a rainbow from an airplane, we might see a complete circle. This is because there is no horizon to block our view, allowing us to see the full, unbroken circle of the rainbow. Section 5. The necessary ingredients. Rainbows don't just appear anywhere. Certain conditions are required for this spectacle of light to occur. First, you need sunlight. The sun must be behind you, low in the sky. Second, you need water droplets in the air. These could be raindrops, mist, or even spray from a waterfall. The smaller the water droplets, the more vibrant the colors of the rainbow will be. Finally, you need the right angle. The angle between the sun, the water droplets, and your eyes must be just right for you to see the rainbow. Section 6. A second reflection. Sometimes you might see a fainter secondary rainbow above the primary rainbow. This secondary rainbow is formed by light that is reflected twice inside the raindrops. The double reflection causes the colors of the secondary rainbow to be reversed compared to the primary rainbow. The red is on the inside and the violet is on the outside. Secondary rainbows are always fainter than primary rainbows. This is because some light is lost during each reflection inside the raindrop. Section 7. Colors in the sky. Rainbows are not just limited to the colors we see in the visible spectrum. There are also infrared and ultraviolet rainbows that are invisible to our eyes. These rainbows are formed by the same process of refraction and reflection, but they involve different wavelengths of light. Scientists can use special instruments to detect and study these invisible rainbows. Infrared rainbows can tell us about the temperature and composition of the atmosphere. Ultraviolet rainbows can reveal information about the ozone layer. Rainbows are a reminder that there is more to the world than meets the eye. Section 8. A universal phenomenon. Rainbows are not unique to Earth. They are a universal phenomenon that can be seen in various forms across the cosmos. They can occur anywhere there is light and water droplets. When sunlight interacts with water droplets in the atmosphere, it creates the beautiful spectrum of colors we see as a rainbow. Scientists believe that rainbows may even be found on other planets and moons in our solar system. These extraterrestrial rainbows might not be made of water, but other liquids or gases. For example, Saturn's moon Titan has an atmosphere that contains methane. This thick, hazy atmosphere is rich in hydrocarbons. Methane can form clouds and rain, just like water on Earth. When sunlight or other light sources pass through these methane droplets, they can create methane rainbows. Scientists think that Titan might have methane rainbows, although they would look different from the rainbows we see on Earth. These rainbows would likely be less vibrant and have different color patterns due to the different atmospheric conditions. Rainbows are a testament to the beauty and wonder of the universe. They show us that the same physical principles apply, whether on Earth or on distant worlds. They remind us that even the most complex phenomena can be explained by the laws of physics. The interplay of light and matter creates these stunning displays. So next time you see a rainbow, take a moment to appreciate the science behind this breathtaking display of nature's magic. It's a beautiful reminder of the universal laws that govern our world and beyond.